Hi and Assalamualaikum. My name is Nur Faiza binti Hamali and today I will be presenting on my assignment 3 for research methodology subject. My research title project was classification of mosquito species using machine learning with wing-based audio. My supervisor is Associate Professor Dr. Muhammad Herman bin Jamaluddin. Next, this is the outline presentation for my project, which is start with introduction, following by problem statement, research question, next research objective, and then following with research scope, literature review, expected outcome, milestone for my project, and then conclusion, reference, and question. As intro of my research project, mosquito remain one of the main significant diseases vector worldwide. It transmits illness such as dengue, malaria, Zika, and so on. In tropical countries like Malaysia, a hot and humid climate provides ideal breeding conditions for mosquitoes. In 2025, Malaysia has already reported 32,299 dengue cases and 21 deaths as early July. It showed a sharp decline compared to the same period in 2024. So accurate and rapid identification of the Aedes mosquito species is essential for effective vector control. Next, let's discuss the problem statement. First, manual mosquito species identification is slow and labor intensive. It will leading to delay vector control responses. 2. Conventional morphological approaches are not suitable for large-scale, high-throughput mosquito surveillance. Third, existing classification tools are not optimized for real-time mosquito detection in low-resources environments, limiting their practical deployment for field monitoring. Now, I will move on the research question. My research addresses the following. This: how effectively can deep learning models classify mosquito species based on wing-based spectrograms? 2. Which deep learning architecture provides the highest performance for the spectrogram dataset? Third, can the selected model be deployed on an embedded IoT device for real-time classification? Now, the objective of this research are as follows. Firstly, to develop machine learning model for classifying Aedes mosquito species using wing-based audios. Second, to compare the performance of different deep learning models for mosquito species identification. Third, to validate the simulation method in a real-time environment using an embedded IoT device, which is Arduino Portenta H7, for mosquito species detection. Next is the research scope. For my research, it will follow these steps. For a simulation model, firstly, will be conclude data collection. Collect mosquito wing-based audio datasets like Aedes aegypti, Aedes albopictus, and Aedes mosquitoes from open source Kaggle. In addition, data pre-processing. It will convert audio to spectrogram image using short time Fourier transform. Moreover, for model development, it involves build and train different deep learning model, which is for compare each model performance. And finally, must include model evaluation. Evaluate model performance based on accuracy, precision, recall, and F1 score, and compare each model performance. And all simulation will be run in Jupyter Notebook application. Next, for research scope, for model implementation. Once the model is selected, we will implement it for real-time deployment on the Arduino Portenta H7 that connect with microphone. This will be involved by uploading the model to the device, performing the real-time inference to detect mosquito species, and displaying the result on the device serial monitor. Next, I will discuss the literature review for this research. This is the literature review table summarizing recent research on mosquito classification using different dataset and method, which is different machine learning model. As shown in the table, Bayesian transformer have demonstrated high accuracy in classifying mosquito species, with 99.8% accuracy achieved by Auto Ahmad. On the other hand, transfer learning models such as ResNet also show strong performance with 89.9% accuracy. In addition, to summarize this literature review, I include advantage and disadvantage of each model. From the comparison, VIT offer high accuracy but require large dataset and significant computational power. In contrast, transfer learning models like ResNet, MobileNet are more computational, efficient, and suitable for real-time applications, but they may not achieve the same level of accuracy as VIT, which Vision Transformer, in more complex tasks. Let's move to the expected outcomes of this research. First is spectrogram images. Spectrogram images generate for all mosquito species. Second, model performance evaluation. The accuracy graph for each deep learning models like ResNet, DeskNet, MobileNet, and VIT with the base parameter settings including epoch, batch size, and learning rate. Third, model performance evaluation table. It includes accuracy, precision, recall, F1 score, and coefficient matrix for classification results. Lastly is real-time detection output. Real-time detection and classification of mosquito species on the Arduino Portenta H7. Now I will talk about the research timeline and milestones for 14 weeks. The research will be carried out over several quarters. The first quarter is involved data collection and pre-processing. Second quarter, it will be involved model development and evaluation, and third quarter, it will involve real-time deployment and testing on the model on embedded devices. Lastly, to conclude, this research will develop a machine learning model to classify Aedes mosquito species using wing-beat audio that will be achieved Objective 1. Second, the performance comparison of different deep learning models will help identify the most accurate and efficient approach for mosquito species classification that will be achieved for Objective 2. Third, the simulation method will be validated in a real-time environment using an embedded IoT device for mosquito detection that maybe will be achieved for Objective 3. Overall, this study will be contribute to faster, more accurate mosquito monitoring, enabling timely responses to dengue outbreaks and improving public health surveillance. This is the list of the references for this research project. Following that, I will answer some questions. First question, what are the main contributions of your research? The main contribution of my research, firstly, development of a machine learning model for accurate Aedes mosquito species classification using wing-beat audio. Next is real-time mosquito detection using embedded IoT device, enabling faster and more efficient mosquito monitoring in the field. Third, enhancement of mosquito vector control by providing a scalable, automated solution for monitoring and early detection of mosquito species. Second question, what are the impacts of your research to the industries and communities? The impacts of my research to the industries and communities is to improve public health surveillance by enabling quick detection and monitoring of mosquito species, particularly during dengue outbreaks. Second, to support for vector control industries with accurate, scalable, and cost-effective mosquito detection solutions. Third, by enhanced community safety by providing tools for timely responses to prevent mosquito-borne diseases like dengue, Zika, and malaria to the community. Thank you.